Hello everyone, welcome back to day 2 of our bond shapes and Vesper theory. Now, how we're going to start this off is I want you guys to pull out your dot diagram worksheet, and I want you to, we did 1 through 20 odds only, now I want you to do the evens only, 1 through 20. So very similar to like what we have here for question number 2. We have hydrogen 2. I want you to go ahead, draw the Lewis structure. And then I also want you to tell me its bond shapes. So we talked about that last time. There's the 3 bond shapes. There is the linear, there is the trigonal planar, there is the tetrahedral. I want you to start with that. Draw that out. Now, why am I making you do the other 10 as a warm-up? And that's because to kind of get you back in the flow of things. Because remember, part 2, part 3 of the lab together is worth 100 points. So I want to make sure that we are as ready as we possibly can be for part 2, part 3. And also, after today, we only have one more set of things to talk about before we walk into the quiz. And that's intramolecular forces, and that's when we're going to start talking about how things stick to each other, and also whether or not something is polar or not. And we need to have a good grounding for that before we talk about it. So that's why I'm having you guys go through it. So go ahead and start taking a look at questions 2 through 20, evens only. I want you to hit the pause button in a quick second. So that's why you guys give a chance to go through it before you just take the answers from me. Because I will tell you this, is that after next class's lesson, we are looking at a quiz focusing on these concepts, doing the Lewis structure. Telling me what the base shape is, tell me what the molecular shape is, and also whether or not that particular molecule is polar or not. This is why I want you to take the time, hit the pause button, then review with me to see how well you do. Alright, so go ahead and pause in 3, 2, 1. And for those who hit the pause button, welcome back. Let's take a look at the questions themselves. All right, so looking at H2, we have 2 valence electrons, so we have 2 dots that we're working with. So there we go, boom, boom. What's that form? Forms a linear molecule. Number 4, phosphorus has 5. My hydrogens, there's 3 of them. They have only 1, so we add that up. That's going to give us a tetrahedral shape. When we look at number 6, remember, our carbon is our host, and we see 4 different things around it, therefore it's tetrahedral. We scroll up here to back up to 8. Oxygen is my host, fluorines are my guest, therefore I have 8 altogether. If I go down to number 10, we have phosphorus again, hanging out with some chlorine atoms. We add up our valence electrons, come up with 26, place our dots. We throw an extra pair of dots up here. Remember, our leftovers, after we've given all our dots to our host, we give to our guest, we give them to the host. Boom. There's 2 right there. That gives me tetrahedral. We're going to look at carbon dioxide. We have a straight line. Therefore, we have a linear shape. If we go on to number 14... Oh, I'm slide down a little bit. Number 14, we pick one of the nitrogens as our guest, one of us the host. 5 plus 5 is 10. Count up our dots. Forms a linear shape. NH3, we have, 5 for nitrogen, 1 for each of the hydrogens, gives us 3, gives us a shape of 8. When it comes to 18, oxygen is our host. We see it move around. There's 1, 2, 3, 4 grouping of electrons, therefore tetrahedral. Then we move to number 20. We count up our valence electrons. 4 valence electrons for our carbons, 2 for our hydrogens, comes up to be 10. And we clearly see that forms a linear shape for us. Now, I want to jump back into our notes talking about molecular shapes. Now, I do need to make a small change to our notes. Instead of NO3, you just scratch that out. We're going to look at NH3 in order to get the proper shape that we want. So now we're talking about molecular shape. And here's the thing, is that you're going to have to be able to memorize your molecular shapes. There's no ifs, ands, or buts. There's only a couple of them that we have to worry about, but it's something that we just have to do. Molecular shapes or molecular geometry, that's a shape that's formed by atoms attached to the electron groups on the central atom. So a little bit different from the base shape. Sometimes they are, a lot of times that they aren't. So, our example. Tetrahedra can form 4 different types of molecular shapes. First one, we have our methane, which is C. Sorry, let me draw my dots out here. CH4. Everything's occupied, drawing a molecular shape. That's going to give us a tetrahedral shape, right? There's 4 things, like we saw before. Now, the name of the molecular shape, this is where things sometimes be a little different. We don't have any just lone pairs, any just electrons by themselves floating around. Therefore, the molecular shape, I'll do it over here. So CH, 1 hydrogen coming out at us, 1 going behind us. It's going to give us the molecular shape of tetrahedral. Now, when we're dealing with NH3, remember our shape, how that's going to go. So we have H, we have one end, we have one end going behind the paper, one end coming out at us. Then we have this lone pair here. So this is actually going to push these, it's going to push on these hydrogens to come a little bit closer. It's going to form a different shape. So base shape would be a tetrahedral shape. But the base shape is going to be what we're going to call a trigonal pyramid. Here we actually have an example of our trigonal pyramid where our electrons are floating up here and it's pushing on these 3 hydrogens here. So there is a 3D model. It's going to make a little bit more sense when I see you, or I can actually show you what this looks like in real time. But basically I'm just taking whatever up here, it's just not there. So the shape of the tetrahedral remains the same, it's just that this is no longer coming out at us anymore. This structure right here, it's gone. We still have the bottom shape stays the same. It'll make sense when I show it to you. It's hard to describe it. We have H2O. So we have O, H, H, dot, 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 dot. We have 2 pairs, lone pairs. So it's going to give me O, 1 hydrogen coming at us, 1 hydrogen going away from us, and just to make life easier, just put the lone pairs on the same plane. The name of this shape is going to be the bent shape, where these lone pairs are going to push the hydrogens closer to each other. And then lastly, we have the diatomic element fluorine, so F2. So 7 plus 7, that equals 14 dots we have to work with. F, 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6. 2, 4, 6, 8, 10, 12, 14. That's going to give us a linear shape. Linear molecular shape. Now the reason why it's not tetrahedral is because even though all of them the base shape is tetrahedral because we have the other electrons. We're talking about what's attached to the central atom. We're kind of ignoring the other lone pair electrons. We're just talking about how the different atoms are in an arrangement. The base shape accounts for the electrons. The molecular shape doesn't. That's kind of what we're going with here. So, let's you guys take a second, write that down. I just need to check something real fast on my end. Please excuse me. I'm going to go stuff over to the next page. Okay. So, now we're looking at BF3. So all these base shapes are still trigonal planar. So that's what we're starting off with. We're going to see if all of them stay trigonal planar. So BF3, so we can go ahead. Boron has, oh, that's what I meant to look up. I do apologize. I was like, what am I doing? So I don't have a periodic table directly in front of me. 5. Okay. So 5 plus 7 plus 7 plus 7, so that's 21, so that's 26 dots altogether. So if we're drawing out our shape, that's B, F, 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 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Excuse me. 2, 4, 6, 8, 7, 8, 4, 6, 8, 2, 4, 6, 8. Okay. We'll check our math real fast. So, that shape is going to be our trigonal planar. That one hasn't changed, right? That's the same. NO2 is where we're going to see the bent shape again. So, N. So let's stretch it out. N0, 0, it's an O. Count our stuff. Excuse me. So this is going to give us a bent shape. And lastly, another diatomic element. Sulfur. Oh, no, sulfur's not a diatomic element. I don't believe it is, top of my head, but it does show up every once in a while sometimes in sets of 2. Nope, it's not in the diatomic 7, so we're okay with that. But it's going to form a single line. So sulfur is, which group is sulfur in? Sulfur is in the same group of oxygen, so 12 dots altogether. 5, 6, so 8, 12, so let's move that over, so that gives me final structure of this. Oh, let's go there, that goes down here. That's going to give us a linear shape. So we're only really adding 2 new things. We're adding the trigonal pyramid, and we're also talking about bent. So we need to account to see if we have those extra electrons floating around or not. If there are floating around, then that means that we have 2 lone pairs for bent. If it is linear, we should be seeing that straight line. So our last group for linear is our Cl2, Cl2, CCl2. So we have our chlorine molecules here. So if we draw this down here, so that's 6 plus 7 plus 7, So that's 14, 15, 16, 17, 18, 19, 20. So we have 20 dots that we're working with here. Chlorine's the middle. Cl, Cl. Chlorines get the dots first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then our host gets the remaining dots. So that's my structure. Cl. So linear can only give us other linear shapes. Same thing with chlorine. I'm going to see the same thing as before, Cl. So if I do that, so that's 14, 7 plus 7 gives me 14. So I'm going to choose 1 as my host, 1 as my guest. 1, 2, 3, 4, 5, 6, 7, 8. Then my host gets the rest, 8, 9, 10, 11, 12, 13, 14. Perfect, so we have an even amount. No double bonds we have to worry about this go around, which is awesome. What shape is that does that look like? It looks exactly like linear as before. So when I see you, I have some models that we're going to use to kind of help so we can see these different shapes. Kind of hard to do on just a recording for what I want you guys to do, but that's what I want you to focus on. So I want you to tackle that first. Then I want you to go back to your dot diagram worksheet and focusing on just the odds, 1 through 20 odds. You've already done the shape, you've done the base shape. Now I want you to do the molecular shape. Give it a shot. Let's take a look at the first one. So I'm looking at CH4. CH4 doesn't, correctly, wasn't exact. Was it straight from the notes that we just did? It may have been, which is okay if it is. It is. So, straight from the notes that we just did, we have tetrahedral base structure. We don't have any lone pairs to worry about. So it means that the base shape is tetrahedral and the molecular shape is tetrahedral. But if I look at number 3, where I had chlorine, 2 chlorines, what shape are my atoms in? Linear. Do they have those other lone pair electrons? The molecular shape, looking at the atoms, is linear. Base shape takes account of the atoms and the electrons. Molecular shape is just looking at the shape of where the atoms are. So I want you to go ahead, work out the other 8 on your piece of paper. Go ahead and what we'll do is that once you are done with that, I will tell you what I want you to do for the rest of the classwork and also some homework talking about the lab itself. So go ahead and pause in 3, 2, 1. All right, so go ahead and take a look at the first page real fast. So we said 1 was tetrahedral, the base shape was tetrahedral, the molecular shape was tetrahedral. 3, the structure, the base shape was tetrahedral, but it was linear. Look at number 5. Number 5, base shape is tetrahedral, but we see that because there's 4 different atoms around it, that's also going to be tetrahedral. Number 7, the base shape was tetrahedral, but we see those lone pair of electrons Because of that, we're going to see a bent shape. Same thing with number 9. We're going to see a bent shape. When I look at number 11, I'm also going to, we said that the shape originally was linear, and we know that linear can only give us one other type of shape. That's linear when we look at the molecular shape. If I look at number 13, base shape is tetrahedral, 1, 2, 3, 4 atoms around it. That means it's also the molecular shape is tetrahedral. Same thing with number 15. 1, 2, 3, 4 different atoms. Number 17, we have a linear shape. Linear can only be linear when it comes to its molecular shape. Excuse me. All right, so we have a trigonal planar here. What were options for trigonal planar? It can either be trigonal planar, bent, or linear. We don't have any lone pairs of electron on either one of the carbons, our host carbon or the guest carbon. Therefore, that means that its molecular shape is also trigonal planar. All right. So that is a little bit of practice with the previous stuff that we've already done. If you'd like to go ahead and try to do the evens for practice before you get into the molecular shapes, that's a great place to do it at. Check with a partner. Make sure you guys are lining your work up well. What you are expected to finish for homework today is part 2 of your molecular shape lab. So, part 2, you're going to check all of your dot diagrams and base shapes to make sure they are accurate. You're going to predict the molecular shape and bond angle. Refer to the molecular shape table as needed. So that's the stuff that we already did. Build one molecule at a time. Once built, check the molecular shape predicted in the previous step. Draw the molecular shape on the attached table to predict the bond angle. And and when I see you, I will be able to check your work to see if you're ready to move on. Now, I will say this, is that when it came to our bond angles, we go back and take a look at our notes. I just want to make sure that we have this. So, when it comes to the tetrahedral, trigonal planar, and the bent, these bond angles all are going to stay 109.5 degrees. What was the bond angle for a linear? 180. If I take a look at my trigonal planar was 120 degrees. For linear, it was 180 degrees. And lastly, for my linears, obviously there's going to be 180 degrees. Just like they were for the base shapes, we want to keep that same energy moving forward. So, in the homework, where did I put mine that I already did? We can do a quick review for part 1 to make sure that your work lines up with mine. So we're using the bond name. So here we have the Lewis dot diagram. Here we have the base shape. As well, give you that. Give you a chance. If you need to press pause to check your answers, do so. But I'm going to slide this up. Okay. There we go. Go ahead and hit pause. So check your answers. 1, 2, 3. Flip it over. All right, so that you've checked your base shape, let's take a look at so when it says name of molecular shape, we're looking with H2O. That comes directly from the notes. We can see that's tetrahedral, but we have two atoms attached to it, so that means we're going to get the bent structure. We're going to get O, H, H. And what was the bonds? The bond angles for our tetrahedral? 109.5 degrees. Let me... So, for a trigonal planar for a NO2 minus, now we have two items attached to our nitrogen with our floating lone pair. So that's going to give us the which type of shape again? Right, there's two atoms attached to the host. That's going to give us the bent shape. So we draw that out. So N. And what was the bond? What was the bond angles for our trigonal planar? 120 degrees. I want you to work the rest of them out for part 2. When I see you next time, we're going to talk about the intermolecular forces, and that's going to be able to tell us whether something is polar or not. That's our goal for next time. So, check your work. Make sure you complete the work. Check with a classmate, and make sure you're doing well. Have a good one, guys.